quiz is graded, so I'll try to get those back to you. All right, if you want to put a title on this here, yes. Yeah. Okay. I'll try to see what I can do about emailing you answers. Okay. I'm gonna see what I can do about emailing answers for those for everybody. If I do it for you, might as well do it for everybody. All right. If you want to put a title on this today, okay, we're going to look at what we call phase shift and vertical shift. All right. Now, vertical shift should sound kind of, you could probably figure out what it is, okay? But phase shift, on the other hand, is a little bit different. Now, let's look at back, before we get into the trig, let's look at algebra just a second, okay? All right. What kind of graph are we talking about with these three? Parabolas, right? X squared is just the upwards parabola. All right. What happens in this second one here to the parabola when we put a -2 inside the parentheses and then square it? It doesn't go up or down.
It turns.
No. Yeah, the first one is. Okay. But what about the second one? What's the -2 inside the parentheses going to do to it? Close. It goes to the right too. Okay. So you remember how we talked about horizontal stuff? The way I called it Luke Tatum. Never does what it says. It does the opposite. So that parabola would shift over to the right too. Okay. Now, that's what we're going to do with our sine and cosine functions today. Okay. So if I see it inside the parentheses, it's going to shift to the left or to the right, and that's called the phase shift. Now, one thing that you have in trig that you don't really have a lot in algebra is you have a coefficient. You might have a coefficient right there, and that's going to change it up a little bit. Okay. Now, what about, now this is what we'll start with. Okay. What's the -2 going to do if it's like outside the parentheses? Right, it's going to shift it down to, right? All right, so to kind of compare this, all right, what this would be like would be this equation, all right? If I had y equals, say, sine of x, and let's say minus pi over 2. Okay, so what's that basically going to do to the function then, the sine function? It's going to move it to the right where pi over 2 is. Okay, now there again, when we throw a coefficient right there, that's going to change it up a little bit. Okay, but that's the basic premise. All right, so what if I do this? What if I do y equals sine of x, and I say -2 on the outside right there? It's going to shift it down to. Okay, now that's what we'll start off with right here. Okay, let's actually look at this graph and how it kind of messes with the amplitude. Now, it's usually a good idea when you have, y'all see the difference in the phase shift and the vertical shift? The phase shift is going to be on the inside. The vertical shift will be on the outside of the parentheses. Now, it's usually a good idea, especially with vertical shift, to use this graph paper, okay, that I've sent you here. Which one was it? Yeah, that's it. All right, let me shrink it down a little bit. Okay, now, can y'all see those numbers on that all right? Do I need to make it a little bit bigger? Maybe a little bit. All right, so now, let's look at this one, okay? And really, vertical shift, nobody really has any issues doing vertical shift. It's the phase shift that I'm kind of worried about you with. All right, let's do a cosine one. All right, let's say we got 3 times the cosine of let's say 2x plus 2. Okay, now let's name everything that we know about it so far. Well, not really. Okay, so let's back up on that. All right, amplitude is 3. Okay, but here's the thing. It's not going to bounce back and forth between 3 and -3 anymore because it's going to be shifted up 2 units. Okay, so if I shift it up 2 units, it's actually going to bounce back and forth between 1 and 5. Okay, now that may not make sense to you yet. Okay, so just stick with me on that. All right, but it's not going to bounce back and forth between 3 and -3 because it's going to be shifted upwards too in just a second. Now, what about the period? Okay, what do we do? 2 pi over b. All right, what's our b value? 2. All right, so 2 pi over 2 would just be pi. Okay, so period is just pi. Now, we're going to label vertical shift. So this is our title, so to speak. And so vertical shift, I'm going to abbreviate it VS. All right, you can do the same thing. Okay, so it's that same thing that we did that to this parabola back, where I put this right here. Okay, right here, right? If I said x squared minus 2, it would shift the parabola down 2 units. Okay, so if I say plus 2, then this is going to shift my graph up 2 units. Okay, now you don't have to say up. If you want to say up, you can. Okay, I'm just going to say 2. All right, so now this is really going to mess with the amplitude more than anything. All right, so what I'm going to do when I have a vertical shift, that's what I actually start with. All right, so I'm going to go up 2, and I'm going to draw something on my graph called the center line. All right, and so I'm going to draw it where that vertical shift is right there. Now, you know how what the sine and the cosine curves, they bounce back and forth, and they just keep crossing the x-axis, don't they? Well, instead of crossing the x-axis, they're going to cross this line of y equal 2. Okay, so instead of starting at the origin and going up 3 and down 3, where are we going to start from? We're going to start at 2. Okay, we're going to start at 2 and we're going to go up 3 and down 3. All right, now, so if I start at 2 right there and go up, y'all see where I'm getting 3 from, by the way, the amplitude? Okay, so if I go up 3, that's going to put me up here at 5, isn't it? And if I go down 3, that would put me at -1. Okay, so instead of the curve crisscrossing through the x-axis, it's going to crisscross through the value of 2. So it's just going to pick up the graph and move it up by 2 units. All right, now let's do all the period stuff. Okay, so let's go out to the fourth one. So 1, 2, 3, 4. All right, what's that one going to be? Pi. Okay. And then, all right, let's half it. Pi over 2. And then pi over 4. Okay. So I got pi over 4, 2 pi over 4, 3 pi over 4. Okay. Now, let's do our graph. Now, let's think about cosine. Normally, we say what cosine starts up at the high point. What's the high point going to be right here? 5, right? Because everything is in reference to this line right here instead of the x-axis now. Okay, that's all vertical shift does. So it'll start up here at 5. Okay, now at pi over 4, where is it going to go down to? The 2. Okay, and you remember what we called this, by the way? That's called the center line. So instead of the x-axis, it's now a center line. Okay, now center line. Center line. Let me write it out for you. Okay, so this is called the center line. And what a lot of people do is they just do a little dotted line, kind of a light dotted line to help them kind of spot that. Okay, so now at pi over 2, it's going to be at -1. All right, at 3 pi, it's going to be back up at 2. And then at pi, it's going to be back up at 5. Okay, now I'm going to draw my cosine curve. All right, so y'all see how all we did was just pick it up and move it up 2 units. Okay, all right, let's do a sine curve for the vertical shift. All right.
It goes to 2
Because of the vertical shift, it starts up going to 2. So when I have a vertical shift, this is what I start with instead of the amplitude. Okay? Yes, exactly. Y'all kind of see what she's seeing? I mean, that's perfect. 2 is the new x-axis. All right? And so when I have a vertical shift, that's like the very first thing I look at. I don't really concentrate on anything. So I go to 2, and then from 2, I'll go up and down 3 units. So if I'm at 2 and I go up 3 units, that's going to put me at 5. And if I'm at 2 and go down 3 units, that would put me at -1, right? Okay. Now let's see if y'all can get it with a sine curve. And let's see if we can kind of picture it ahead of time. All right. Let's do, let's throw in a negative here. -2 times sine of 3x. And let's say like -4. You know, these are the only graphs here that I really like to do. Ooh, mess that up. On graph paper because of the vertical shift in them. Okay. Now, so let's list out everything that we know so far. Amplitude is 2. Okay. Period. Let's see, 2 pi over b. All right, what's our b value there? 3. So it'll be 2 pi over 3, kind of an odd period. All right. Now, here we go with our new stuff. Vertical shift is going to be what there? -4. All right, what's another way you could say it if you wanted to? Down 4. All right, I'm just going to say -4. Okay, so now that's really what I'm going to start with is -4. So I'm going to go down to -4, and that's where my center line is going to be. I'll do it in a different color so it'll stick out for you. Okay, now from -4, y'all picture, what am I going to do from -4? Right, go right, up to and what else? Up to and down to. Because amplitude goes up and down, right? Because it's the absolute value. All right. So from my -4, I'm going to go up to and then down to. All right. So y'all see how it's going to, where is it going to bounce back and forth in between? Yeah, -2 and -6, which normally, what if I didn't have this vertical shift of -4, then it would bounce back and forth between +2 and -2, wouldn't it? But if I shift it down 4, it's going to bounce back and forth between -6 and -2. All right. Now, let's do the rest of the stuff. So let's do the period, and let's count out our units here. So let's go out to the 4th one. All right. So guys, what's the 4th one going to be there? All right, 2 pi over 3. All right, it's kind of hard to half that one. All right, what's half of 2 pi over 3? 2 pi over 6, which would be pi over 3. And then half of that would be pi over 6. Okay, so we're counting by pi over 6. So pi over 6, 2 pi over 6. This one would be 3 pi over 6, which is pi over 2. All right. Now, let's draw the curve. Now, normally with the sine curve, what do we keep saying over what sine starts at the origin and goes up. It's not going to start at the origin anymore because I've shifted it down to -4. So now what we're going to say is sine starts at the center line. Now, it's going to go down because that's negative right there. Okay. So where is it going to actually start at? Yeah. And then go down to -6. Okay. Did y'all follow that okay? All right. Now, so at pi over 3, where is it going to be? -4. Okay. And then pi over 2, where is it going to be there? Yeah, -2. Okay. And then 2 pi over 3 is going to be back at -4 where it started. Right. Instead of the x-axis. -4 is like the new x-axis. Okay. So instead of going up and down 2 from 0, you go up and down 2 from -4. Okay. Now, y'all do this. Look at your, oh, let's do this, by the way. Well, go ahead and do this while I'm getting ready. Get out your graph and sine and cosine worksheet, the one that I gave you way back on Thursday, okay? Because we're going to go back and hit some of these problems we skipped earlier, okay? I'm going to actually get you to do one out of the homework real quick, okay? Now these are actually at the end of the lesson, which is kind of weird because I think that vertical shift is probably much easier than phase shift. But all right, look at number 53 on that worksheet, and y'all try to sketch that one out. Okay, 53. Okay, and that's actually one in the homework, so you can have it done. And while you're doing that, I'm gonna set up a calculator here. Yeah. Okay. I might have to get you to call me some out in a minute. I need to give you a backside of that too. I'll get to you later. All right. Now, which one did I tell you? I forgot. 53. Okay. All right. Y'all try that one out, and we'll go over it. Kind of stop where you're at here. All right. And let's look at this from the graphing calculator. So, you know, when they're sine and cosine curves, they're really easy to check on our graphing calculators, aren't they? Okay. Now, and let me throw this in. You can also check secant and cosecant by checking the sine and the cosine curve too, right? Because when we do secant and cosecant, we start with sine and cosine. All right. So use your graphing calculators here. Now, just watch this one, and what we'll do on yours is we'll check the one that y'all just graphed. Okay. So let's talk about what I'm gonna really have to figure out here is how would I set the window to check it. Okay. So on my window here, all right, look at my information here. Look at the graph that I got. Okay. So let's see. What about my x min and max there? Uh-huh. 0 to 2 pi over 3, right? Because we're thinking x. Okay, left to right. So 0 to, all right, I'm going to put in now 2 pi over 3. Okay, now what about my x scale? That's what I'm counting by. Pi over 6. Now, here's where a vertical shift would really kind of change what we did before. What about my y min and max? Y min would be -6, and y max would be -2. Okay, so -6. All right, -2. Probably still going to scale the y's by 1. Now I can check it on my graph here. Okay, let's do this. All right, is that pretty much what I had there? Yeah. Okay, let's notice. All right, that's like what, -4? It's going down 2 and up 2. Okay, if I really wanted to see it better, let me think about it this way. Let's let the y min be 0 so I can see the x-axis. Uh-oh, what did I do wrong? Oh, I'm sorry. Y max would be 0, and then y min would be -6. All right, so you see there's the x-axis. What's happened? This moves, it's been shifted down 4 units. Okay, all right, now let's look at the one that you guys did, and I'll do it with you here. Okay, y'all can walk me through it. All right, what was it? Call it out to me. All right, so it wasn't really complicated. Didn't really have much period change and no amplitude change, did it? Okay, so amplitude was what? 1, all right. Period was just 2 pi, because you didn't have a coefficient, right? You don't have a coefficient, it's just 2 pi. All right, now here's the new stuff. Vertical shift, 2. Okay, so now when I sketch this graph, we're going to start with that 2, right? All right, so see if somebody can kind of tell me. So I'm going to go where to? Up 2, okay? And then once I get to up 2, where am I going to go from there? Up 1 and down 1, right? So we start at the 2, and if we went up 1 and down 1, then it's going to bounce back and forth between 3 and 1, right? Did y'all get that on your graphs? Okay, so watch. I'm going to go 1, 2, and then from 2, I'm going to go up and down 1 with my amplitude of 1. So it's going to go up to 3 and go down to 1. All right, right. So where is my center line? At 2, right. So that's like the new x-axis. Now, let's just do everything else like we've been doing. All right, so period was 2 pi. 1, 2, 3, 4. Hang on, I got to straighten that out. That's bothering me. We got 1. Now it's like going up. 1, 2, 3, 4. All right, so let's see. Period was 2 pi. Half that's pi, half that's pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. All right, now it's a sine curve. We used to say sine would start at the origin, but now it's going to start at the new origin, which will be the center line. So is it going to start at like 2 or 3 or 1? At 2, and then it's positive, so it would go up. Okay. All right, now talk to me. Did y'all do okay on this one? Yeah. So, and what normally here's the mistake people would make. Where should that go? Right, should go to 1, not back to the x-axis, right? So it can go right there, and then back at the center line. All right, now talk to me. We've got a handle on vertical shift now. Okay, now I'm going to change my mind a little bit. I was going to say I have up there no homework, but I want y'all to do the vertical shift ones for homework because you'll do fine on your own with those. Okay, that's the 53 through 59 part. All right. No, I just think you're going to be able to do that okay by yourself. it's the other part that I want you to do with me tomorrow while I'm monitoring you in class. Okay, and that's this phase shift stuff. Okay, so phase shift tends to give people the most problems out of all the stuff that we do with the tree graphs. Okay, so let's look at what phase shift does. Now, I'm just going to make sort of just a generic equation right here and explain what phase shift does. So let's say we got plus or minus A, my amplitude is just going to be the absolute value of it. All right, and let's say times, so we got sine of bx, okay, and we're going to say, hang on, I did that wrong. There we go. Plus C. Okay. Now, we know amplitude, we know period, okay? Let's just write these real quick. All right, amplitude is not A, but it is the what? Absolute value of A. Okay. Period, how do I find the period? 2 pi divided by B. Okay. Now, here comes phase shift. Now, you think phase shift would probably be like this number right here, right? Now, let's go back to the very beginning what I started with. All right. So, right here. So, remember what we said that would do the parabola? It would shift it to the right, too. So, it goes in the opposite direction, doesn't it? Okay. Now, one thing you have to consider is the coefficient there, too. All right. So, if you just had to guess, let's go back to where we were at here. All right. How would you think this would move the graph then? To the left, C units. Okay. And that's almost right. What you have to do is you actually have to, it's going to shift it left, the opposite direction, but you have to put it over the coefficient B. Okay. So the phase shift, this is what I'm going to memorize, is the opposite of C over B. Okay. So it's going to take the graph and shift it. In this case, since that would be negative, it would shift it to the left. Okay, so you remember how the horizontal shifts, which is a phase shift, always goes in the opposite direction, didn't it? All the way back to Algebra 2. It never went the way that you thought. It was like Luke Tatum. Yes. Right. Okay. So, right, if it was like that, if this was negative right there, the opposite of negative would be positive. So when this is positive, like it is right here, this would shift it to which direction? The left. And if it was negative, it would actually shift it to the right. Okay. Now, let's add one more thing. And let's see if this will actually cover everything now. What is that D going to do? That's the vertical shift. Okay. So the vertical shift is just D. And with vertical shift, it's just like when we added the +2 on the outside of the parentheses, go way back over here. This did what it said, didn't it? It shifted it down to. So vertical shift is really straightforward. It goes in the direction that it's supposed to. Okay. Not particularly. Now, I tend to start off with vertical shift. Okay. Now, here's the bottom line. You're not going to have a problem that's got all four. Okay. Usually with vertical shift or horizontal shift, it'll have like one or the other. Okay. And the key is going to be the parentheses part. All right. Now, let's look at one that's got a phase shift to it. Okay. And what I'm going to do is I'm going to look at one of the even problems kind of out of your homework set here. All right. So let's see. All right. Let's look. Let's look at number 20. Okay. This is a good one. All right. You got y equals the sine of 2x minus pi over 2. Okay. Now, let's notice the difference. I'm just going to write this down real quick and then erase it. What's the difference there? Right. This one would be a vertical shift of down pi over 2. Does that make sense? And then the other one's going to be a horizontal shift, okay, or a phase shift. So it's the parentheses. When I get it in the parentheses, there's my phase shift. That's the key. Now, let's go with everything that we know so far. Amplitude is just what? 1. Okay. All right. Period. 2 pi over b. What's the b value? 2. All right. So you get 2 pi over 2, which is just pi. Okay. Now, and I'm going to say PS for phase shift. Okay. Now, let's do the formula first. What did I say the formula was here? The opposite of C over B. Okay. So it's the opposite of this value divided by that coefficient right there. Okay. So let's see. Let's write that out. So opposite of C. So it's not going to be negative pi over 2. It's just going to be pi over 2. So it'll be pi over 2 divided by 2. Now let's calculate that out. Okay, so that would be pi over 2 times 1/2. So we're going to get pi over 4. Okay, now notice this was negative, right? So that means my graph is going to shift to the right by pi over 4. Okay, now remember how sine, we used to say starts at the origin or starts at the center line? All we're going to do is just scooch the graph over and start at pi over 4 instead. Okay, now let me sketch a graph here real quick. All right, so let's see, no vertical shift. So we'll just start with amplitude, which is 1, and -1. All right, let's go out to the period. 1, 2, 3, 4. All right, what was the period there? Pi. Okay, so help me count here. Half is going to be pi over 2. All right, half of that would be pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4. All right. Now, here's where my phase shift is going to come in. Okay. Normally, we would say, what was this, a sine graph? All right. Normally, we'd say sine would start at the origin and go up. But instead of starting at the origin, it's going to shift over, and it's going to start at pi over 4. Okay. So now, it's going to start right here. So it's like I'm going to take the sine graph and shift it over. Okay. Now, here's the thing. When I start from there, and if I go out to pi, that's not going to give me a full cycle, is it? Well, I need like 4 units to get a full cycle. So, right, if I shift it over to the right by 1 unit, I'm going to need to add a unit to my graph. Does that make sense? So if I'd have went over 2 units, like if I'd have had a phase shift to pi over 2, I would need 2 more units. All right. So I need another unit over here, don't I? Right, that would be 5 pi over 4 because you're counting by pi over 4. You got pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So this one would be 5 pi over 4. Okay, so now y'all talk to me. Y'all see why I'm adding a unit over there? Okay, let's talk about this. What if it would have been negative pi over 4? Right, we would have moved a unit over to the left, and we would have had to add a negative pi. We'll do a negative one next. Okay, but now instead of starting at the origin, we're going to start at pi over 4 and do our sine curve. So is it going to start on the x-axis right there? Yeah, because sine, what, normally starts at 0 and goes up. So it's still going to start at 0. It's just going to be scooted over to pi over 4. All right, so where's it going to be at pi over 2? At 1, all right. And then at 3 pi over 4, it'll be at the origin or at the x-axis. All right, and then at -1, it'll be at, I'm sorry, pi, it'll be at -1. Now see, if I stop right there, I wouldn't get a full cycle, would I? The full cycle has to go back to where it starts. So that's why I needed to add that extra 1 right there. Okay, now there's my graph. Okay. Do what now? Yeah. So it's the sine curve. That's why we started it. All right. The phase shift, okay, is opposite of C over B. Okay. So pi over 2 over 2. All right. Then you got to calculate. So it ended up being pi over 4. Notice because it was minus, it actually shifted the graph over to the right. Okay. Now let me show you this visually what happens. Let me draw this without the phase shift. Okay. And this is why I do this like on the smart board. If I just did it without the phase shift, I would start at the origin and then go up, wouldn't I? Okay. Now, what does the phase shift visually do to the graph? It just scoots it over, right? So that's all it's doing is taking that and scooting it over. Does it visually kind of help y'all see that? Isn't that awesome? That's what smartboard's for. Okay. So you just take it. See, if y'all had like smart paper, then all you would have to do is just draw it and then pick it up and pull it over and you'd have the graph. Yeah, smart mini boards. Yeah, that would be cool. We could call them iPads. All right. Now, let's talk about this on the graphing calculator. Okay. So one of the things that I would do in my graphing calculator for my X max and X min, I would do an X min of 0, but instead of my X max being just pi, I would do 5 pi over 4. And what you would see on the calculator would fill this part in too, which we don't need to fill it in because all we need is just one period. Okay. Now let's look at another one, and this time let's do one that's going to shift it in the other direction. All right. Let me find this one. All right, let's try this one. I'm going to do number 46. Okay. All right, we got y equals 4 times cosine of 2x minus pi. Well, let's see. That's going to shift it to the right, though. All right, I'm going to just change it up. So I'm actually not doing number 46. I'm going to do a version of it. So make it plus. Okay. So can y'all tell how that's going to shift the cosine graph? It's going to shift it which direction? To the left. Okay. Now is it going to shift it left by pi, though? Not exactly. Okay. Pi over 2. All right. Now let's watch it unfold. All right. Amplitude would be 4. Okay. Period. 2 pi over b. All right. What's the b value? 2. All right. So it works out nice just to give me pi. All right. Now, so how do I know that this is a phase shift and not a vertical shift? The parentheses, all right? Because the pi, the plus pi is inside the parentheses, not out. Now, what was the formula for it there? What? Opposite of C over B. All right, so y'all tell me what would that give me then? Yeah, negative pi over 2. So now, y'all see how that's going to shift it to the left by pi over 2? Okay, which is going to be 2 units. Okay, some people aren't that far yet, though. All right, now let's start sketching the graph. I changed it. I changed it so we could have a shift to the left instead of the right, like on last example. All right. Now, so let's start drawing it. Okay, and I'm gonna let you guys kind of talk me through most of it. All right. Tell me something to do on. Okay, amplitude. All right, 4 and negative 4. Okay. What else? All right, 1, 2, 3, 4 out to what? Pi. Okay. All right, so halfway, pi over 2. Pi over 4. All right, so I'm counting my pi over 4. Pi over 4, 2 pi over 4, 3 pi over 4. Okay, now I'm ready to start with my phase shift. Okay, so my phase shift, let's really focus on it there, is negative pi over 2. So normally with cosine, this was cosine, right? Where would we start off without the phase shift? We would start up at 4, right? We'd start right here, wouldn't we? But we're not, because we're shifting it over to the left. So where are we going to actually start from? Negative pi over 2. Okay. Now, well, let's see, where's that going to be, negative pi over 2? Well, where would this one be? Yeah, negative pi over 4. And then the next one would be negative pi over 2. Now, do y'all see how that's shifting over 2 units to the left? Y'all see it? Okay. So instead of starting right here at 4, on the y-axis, we're not starting on the y-axis anymore, but we're going to start at negative pi over 2. All right? So up at 4, though, right? All right. So how come it's not right here that I would like to start on the? It's cosine. All right. So if it was sine, I'd start right there. All right. Since it was cosine, I'm gonna start up right there. If it was negative cosine, we'd start at negative 4. All right. So now, all right. So at negative pi over 2, I'm up at 4. All right. Where am I going to be at negative pi over 4? On the x-axis, 0. Okay. And then on the y-axis, where is it going to be? Negative 4. Okay. At pi over 4, it's going to be back at 0. Now, have I made a complete cycle yet? All right, I got to do how many more? All right, one more. All right, so pi over 2, you're going to be back up at 4. All right, so now let's fill in my cosine curve. All right, now let's look at it on the graphing calculator. Okay. All right, because really what you got to learn how to do is set the window so you can check your graph correctly. Okay, it's not the punch it in part. All right, so let's see, it was, all right, y'all punch it in with me. All right, 4 cosine of 2x plus pi. All right, it's the window here that you really need to kind of learn how to set. Let me get this set up so I can, so it won't disappear on me. All right, so let's go to the window. Let's see if you guys can figure out all the mins and maxes and scales and all that kind of stuff. Okay, so what about my x min there? Yeah, negative pi over 2. All right, y'all see why? Because we backed up to the left, didn't we? All right, so negative pi over 2. All right, x max pi over 2. So really and truly, we didn't need 3 pi over 4 and pi, did we? Okay, because we backed up 2. All right, so let's see. What did y'all say, pi over 2? Over 2. All right, now what about my x scale? Yeah, pi over 4, that's what I'm counting by. All right, y min and max, yeah, negative 4. All right, positive 4. Yeah, y's, we're just counting my ones. All right, so now let me do a graph. Let's check it. Okay, so is that what I've got there? Yeah. All right. So all your sine and cosine graphs you should be able to fix. Now, let me tell you, we'll get y'all to do one out of your homework here in just a second. But the thing that people mess up most on phase shift is the direction. They do it in the wrong direction. Okay. And I can see why they do that because, again, it goes back to what does that look like it would do? Looks like it would shift it to the right, wouldn't it? But it goes in the opposite direction. And it goes all the way back to the Algebra 2 graph when you first started with parabolas. They shift left and right in the opposite directions. All right, now, question, what were you going to ask? All right, you go to, all right, everybody listen to this so I don't like have to do this 5 times every day, okay? When your axis gets turned off, all right, you go to Format. It's above the zoom button, okay? So you go to Format, and you see where it says axis on and axis off. Be sure it's turned on. Okay, now nobody asks me that anymore. I'm gonna smack you if you do. All right, now, all right, let's do this, okay? So you're gonna do the vertical shift ones for me tonight for homework, which is gonna be the 53 through 59 part, okay? All right, now y'all see if you can do number 19 for me, okay? Y'all try number 19. Yeah, just the odds on all of these, okay? 53 through 59, I want you to do at homework. Tomorrow, I'm just gonna let you guys work in class on the phase shift because I want to be monitoring you when you do your phase shifts, okay? Because they're gonna be pretty tough. All right, y'all try to do number 19 with me now.
So we have to do all those odds.
Yeah.
Okay, he's doing 19 up there.
Right, at homework, okay? Because this is a phase shift. I want you to be able to do a phase shift for you. All right, somebody want to come up and do it up here? All right, come on.
Shut up.
Everybody, how's that going to shift the graph to the right by quick?
Did I extend it or something?
Yeah. Right. So it's going to start. It's not really going to start on the y-axis. It's going to start at So is she going to need more stuff off to the right or more stuff off to the left?
Wow, to the right.
Right. Okay. So
And it's gonna start at pi. As that is. God, am I doing this right?
yeah, keep going. All right, let's back up and let them look at it.
Sorry.
All right. So it's really not going to start. Was this a sine curve, by the way? All right, it's really not going to start at the origin. It's going to start over at pi over 2 on the x-axis, right? So that's scooting it over how many units? 2 units. So we're going to have to add 2 units on which side? To the right. So add 2 more units. Right, 5 pi over 4. And then, yeah, 6 pi over 4 would be 3 pi over 2. Okay. All right. Right. All right. So sine curve. It's going to go up. That's right. Mm-hmm. That's it. There you go.
Boom shakalaka, Tatum.
All right. Now,
There it goes.
I'm going to go ahead. Go ahead and sit down. I'm gonna throw it in the calculator and show you something, okay?
Alright, okay, good.
Well, never mind. See y'all tomorrow.